Today we are going to learn how to solve systems of equations by graphing. When we are working with systems of linear equations, there are at least two variables and at least two equations. A solution to the system is an ordered pair that satisfies both equations. So if you're given just an ordered pair, you can plug it in and see if it is a solution to both equations. If it is, you know it would be a solution. If not, it would not. So we're going to try that for our first problem here. So let's look at number 1. Number 1, we're going to plug in 5 for x and 2 for y. So we're left with 3 times 5 minus 2 times 2 is equal to 11. Well, 3 times 5 is 15, minus 4 is equal to 11. 15 minus 4, 11 does equal 11. So the order pair satisfies the first equation. So now we have to check the second one. So let's plug this in. We have negative 5 plus 6 times 2 is equal to 7. Negative 5 plus 12 equals 7. 7 does equal 7. Since the solution satisfies, or since the ordered pair satisfies both equations, we know that 5, 2, in fact, is a solution. I want you to pause the video and check to see if number 2 and 3, if their ordered pairs, are solutions to the system. All right, you should have solved 2 and 3. For number 2, for the first equation, you would have had negative 15 is equal to 15, which is not true. Since the first ordered equation does not match ordered pair, since it's not a solution, we know that that ordered pair cannot be a solution for the system, so we don't have to go any further. The second one we're going to look at, if you plugged it in the ordered pair into the first equation, you would have had negative 15 is equal to negative 15, which is true. And then you would have had negative 3, which equals negative 3 for the second equation, which is also true, which tells you that negative 2, 1 is in fact a solution to your system of equations. All right, so now that's only if you have an ordered pair. However, if you have two equations and you want to figure out what the solution is, you can solve by graphing them. The solution will be where the two graphs intersect. That would mean that the ordered pair would satisfy both of the equations. All right, so you always want it in slope-intercept form in order to graph it, which we will start by doing since they're both in slope-intercept form. So let's graph the first one at negative 3 for our y-intercept, and then a slope of 2. All right, up 2 over 1. 2 over 1. All right, and down 2 over 1 and down 2 over 1. So this would be our first line. And then we can graph our second line as well. So we have plus 2, and then we have a negative 1/2 slope. So down 1 over 2, down 1 over 2, down 1 over 2, up 1 over 2, up 1 over 2, and up 1 over 2. Here is our second equation. So you notice that you have a intersection right here. This would be your solution because it's where both lines intersect. So you would have the solution of 2, 1. And now you can plug it in to check to make sure. So let's look at this. We have 2 times 2 minus 3 should equal 1. 2 times 2 is 4. 4 minus 3 is 1. So it does, in fact, satisfy the first solution, or first equation. And now we can check the second one. We should have negative 1/2 times 2 plus 2 should also equal 1. Negative 1 half times 2 is negative 1, and negative 1 plus 2 is 1, which in fact does satisfy that equation, so our solution would be 2, 1. Alright, so now for the back. On the back, I want you to try. Make sure you have your equations both in slope-intercept form before you graph. I want you to graph, find your solution, and then check to make sure that solution is correct. So pause this video right now. When you are done, you can start it again and check to see if you are correct. All right, you should have solved this system of equations. When you take 4x minus y equals negative 1 and put it in slope-intercept form, you should get y equals 4x plus 1. And when you graph both equations, you will get an intersection at the point negative 1, negative 3. When you plug in negative 1, negative 3 to each equation to see if its solution, they do in fact both check out. So we know that negative 1, negative 3 is in fact the solution to our system. Right, so when you are dealing with systems, the point, if it has one solution, right, where the point intersects, or where the two lines intersect at one point, that is called a consistent and independent solution graph. Right, the numbers of solutions, you only have one, and you put it in the form of x, y. If you have no solutions, that is inconsistent because your lines are parallel. You will have no solutions, which means that there are no solutions. So you'd write your solution as no solutions. Lastly, if you are graphing the same exact line, that type of linear system is called a consistent dependent linear system. In this case, you have infinite solutions, and you would write your solutions just as infinite. Alright, so again, if you have one solution, that's a consistent independent graph. If you have no solutions, parallel lines, that's inconsistent. And if you have the same line, that's a consistent and dependent, and there are infinitely many solutions. This concludes our notes for systems of equations by graphing, and I hope that helped.